Hello, and welcome to Drexel University's Microfluidics lab. This is the low Reynolds number flow instructional video, where we'll be covering the procedure step by step. This lab will use two devices to teach 6 objectives. By the end of the experiment, you should understand low Reynolds number flows and microchannels, know how to generate multiple laminar streams, observe diffusive mixing, calculate and measure diffusion length of small particles, explore chemical gradients via diffusive mixing, and finally, understand the diverse applications of multiple laminar streams in microfluidics. We will be using the following materials: 2 5mm syringes with tubing, blue food coloring, a pair of blunt forceps, about 100 milliliters of water in a beaker, invisible tape, a syringe pump with at least 2 stations, and a microscope with a camera. Begin by connecting one end of a tube to a syringe and insert the other end of the tube into the water, taping the tube into position. Then pull back on the plunger, filling the syringe. Remove any bubbles by keeping the tube submerged while turning the syringe upside down and tapping on the side, dislodging bubbles and sending them towards the needle. Depress the syringe, sending the bubbles through the tube and out into the beaker, leaving just 4 milliliters of water. Here's a demonstration of air being removed from the syringe. It is very important that we keep air bubbles out of the system because bubbles will be more compressible than the fluid and will tamper with the results. Once complete, fill the second syringe with food coloring using the same syringe loading procedure. Now you want to check to make sure that your syringe pump is set appropriately for your syringe diameter and volume. Load both syringes and lock them into place. Keeping the ends of the tubes submerged in the water and the dye will ensure that the air stays out of the system. We are now ready for the devices. Select the multiple laminar streams chip and secure it to the microscope stage with invisible tape on both sides. Locate the tubing on the multiple laminar streams chip and insert the tubing into the 2 adapters. It may help to use the forceps to grab the tube a few millimeters from the end in order to push it into the adapter. Once the 2 tubes are secure, we're ready to begin. White balance the microscope camera by entering the image settings in your software and selecting auto white or a similar feature. Make sure you do this in a blank area where there is no dye or prominent features. Set your exposure settings to manual to ensure that all your images have the same lighting properties. Consult the lab manual and set the syringe pump to the slowest flow rate. It may take a while for the channel to fill up at first and several more minutes for the flow to reach equilibrium. As you vary the flow rates, it is important to start with the slowest first in order to avoid pressure errors. Our flows come together, but because the Reynolds number is so low, there is virtually no turbulence. Instead of combining, the 2 liquids flow side by side, and since the flow is streamlined, the only mixing that does occur is due to diffusion. Even though they flow down a single channel and would form a nearly inseparable solution otherwise, the flows can be easily split and separated downstream. We will capture several images along the length of the channel to calculate diffusion length at various times. Capturing the inlet is important because at this location, diffusion has not occurred yet, so in our analysis, this image will serve as our control. We can capture several more images along the length of the channel, observing how diffusion increases with time. The written manual covers image processing and will help you calculate results. Different flow rates will result in different diffusion lengths. Look at some of these examples. For the gradient chip, repeat the syringe loading procedure if necessary and connect the tubes to the inlets of the new chip. The purpose of a gradient chip is to form an array of chemical concentrations at the outlet. Vary the flow rates and compare your results to these images. This concludes our instructional video. We hope that you've enjoyed what you've seen and that it helps explain the procedure for this lab. You're about to get a hands-on experience into the fun and exciting world of microfluidics.